All right. So this is ML 114, just practice ensemble learning and random forests. So first we're going to need a data set. And this, I think, is just the moons data set again that we've used before. Yeah, make moons. So it's going to create a data set where the boundary between the two colors is a curve. And just to be a little bit more difficult than the ones that require a straight line. Right, so we want to separate those. And so we're going to use a logistic regression, support vector machine, and random forest classifier. And that's what this makes. So if you look at the code, here's where it makes three of them: logistic regression, random forest, and support vector, or I thought it was a support vector machine. It's SVC. Let me see what that is. Support vector machine. Yeah, it is a support vector machine, I think. I'm not quite sure why it appears there as SVC, perhaps support vector classifier. But anyway, that's what makes the three classifiers of different types, and then is going to combine them together to get the result. And so each one by themselves has a certain accuracy, see 86, 89, and 89. But when you combine them together, it has 91% success. So that's what we wanted to see. Combining weak classifiers can make one strong classifier. All right. And now we can, this uses hard voting, as we talked about it before, where it's basically just going to see which one 2 out of 3 chose by making each one of these weak classifiers do the entire job of classifying the dots. But with soft voting, we'll take the analog signal out of them and combine that, and that should be more accurate because it will include not only the final verdict of each classifier, but it will include the confidence each classifier has. And so with soft voting, we go from 91% to 92% success. So now we can make a forest by bagging, making random samples of the training set to train predictors. So this will make a forest with 500 trees, each trained on a random subset of the data, so they will make an independent an estimate of the result. All right, here's a single decision tree, overfits the data here, making a ridiculous shape that fits this particular data set. But with bagging, it automatically regularizes itself. And you can see that it is capable of being very jagged here. So it really does include contributions from highly complex decision trees. But by combining 500 different decision trees, it does a pretty good job of following the actual boundary between the dots. All right. And there's accuracy. The end accuracy of this one is over 90%. All right. And so now you can make one with only 5 trees instead of 500 and see how well that works. And you'll see this is the one with only 5 trees. It's still got quite a bit of overfitting, even a disconnected region up here like that. And so you see what the accuracy is. And now we can try AdaBoost, where you have a series of predictors that are not independent measures of the classification, but each one of them tries to improve the previous one. It's successive approximation. And so this one, AdaBoost, will increase the weight of instances that were incorrectly predicted by the previous predictor. So this is the one that does that with 5 iterations of AdaBoost. Got to get the whole thing. All right. All right, and this is the one with too high a learning rate, so it jerks back and forth. Here's the first, after with only the first estimator, and here's adding the second one to try to improve it. But the third, fourth, and fifth, instead of getting better, move too far and jerk away from it, so it's only 67% accurate. The one on the right has a lower learning rate, so it does converge to a good boundary and have an 87% success. And then you can try changing things here with different numbers of cycles and see how it goes. Here you plot only the final result, you can see it can get quite good. So there's a few things to do there to practice these. I must say the biggest surprise for me is that you casually make 500 trees. But remember, decision trees are extremely efficient, fast to make and very fast to run. So you can run hundreds of them without a ridiculous amount of processing. All right, so I'm going to stop this recording.